guys, this is Dr. Garima Agarwal from Manipal University, Jaipur, and our today's topic is complex number, which is the unit 10. Today I am taking this unit 10. We'll discuss unit 6, 7, 8, 9 in the upcoming lectures, right? First of all, I would like to discuss the complex numbers. So in this lecture, we'll discuss the concept of complex numbers, the most important De Moivre's theorem for complex numbers, limit, continuity and differentiability for complex numbers, and Cauchy-Riemann equations. These are few subtopics of complex numbers that we are going to discuss today. So the first thing is, what is complex number? How we can represent it? We can represent the complex number by this iota sign. This I can be pronounced as iota, and the value of iota is root minus 1, which is the imaginary value, right? X plus iota y is called the complex number, like 3 plus 2 iota. This is the complex number, where 3 and 2 itself are real numbers, right? 3 is a real number, 2 is real number, right? Or let's say I write 3 by 2 plus iota, which is also a complex number because minus 3 by 2 is a real number and the coefficient of iota is 1, which is also a real number. So this concept is also known as complex numbers, right? So x plus iota y is known as complex number, where x and y itself are real numbers, element of real numbers, right? In ordered pair, we can represent this complex number as x comma y, right? Now if we want to add two complex numbers, like if I want to add 3 plus 2 iota plus 7 plus 5 iota, let's say I need to add these two complex numbers. This is a complex number, this is a complex number. Then how we'll add it? We'll add this real value, or we can say the real part, 10 plus the coefficient of iota is 2. Here the coefficient of iota is 5. That means 5 plus 2, 7. So this is the addition of these two complex numbers, right? Am I clear? Then how we can multiply two complex numbers? This is the formula to multiply two complex numbers. x1 comma y1 means x1 plus iota y1 times x2 plus iota y2, right? Which is equals to x1 x2. We will multiply these two terms, x1 x2, then x1 y2 with iota, then x1 y1 times x2 with iota, फिर iota y1 into iota y2, right? Iota y1 iota y2, that is iota square y1 times y2. If the value of iota is root minus 1, then iota square will be minus 1. So we can write iota square as minus 1. This is the formula for multiplication, right? In this complex number, z is equals to x plus iota y. X is known as real part and y is known as imaginary part, right? Clear? If let's say we have a term like x plus iota y is equals to 2 plus iota 3, that means x is equals to 2 and y is equals to 3. Am I clear? Right? This is mentioned over there. Now, complex number satisfies few properties for addition and for multiplication. So first of all, we'll discuss few properties of addition. The first property is closure property. So let's say we have two numbers z1 and z2. Let's say z1 is x1 plus iota y1, or we can write it as x1 comma y1. These are just the notations. Similarly, z2 is x2 plus iota y2. Then addition of z1 and z2 can be written as, how we can find the addition? Just add the real part and the imaginary part, that is x1 plus x2 plus iota y1 plus y2. So this number is also the element of complex number. That means complex number satisfies the closure property, right? Then commutativity, again complex number is commutative for addition. If we operate z2 plus z1, we'll get the same value, right? Also complex number satisfies the associativity for addition. Then existence of identity. 0 is the element of real number and 0 is the element of complex number as well, right? So for addition, we know that 0 is the identity element. So identity is also exist for the complex number for addition operation. Then inverse also exists because minus x minus y is the element of real numbers. So inverse is also exists for the addition for complex numbers. And say that complex number is an abelian group with respect to the addition, right? All these properties are for group. Closure, associativity, identity, inverse, all is the property, and commutativity. All 5 properties are for abelian group, right? So complex number satisfies all these 5 properties. That means it is an abelian group. Then for multiplication, again it satisfies closure law, commutativity, associativity. Associativity also exists for multiplication for complex number. Then identity, that is 1 0, which is also exist for complex number. And then inverse. Let me explain this. In this previous slide, we said that 1 0 is the inverse for multiplication, right? Because if we multiply xy by 1 0, we'll get xy itself. So 1 0 is the identity for complex numbers. Then inverse, what will be the inverse? Let's say u and v is the inverse for xy, right? So the multiplication should be equals to 1 into 0, 1 0, right? So let's multiply these two numbers, we'll get this term, which should be equals to 1 and 0. The first value will be equals to 1 and the second value will be equals to 0. Then by solving these two terms, we can find the value of u and v, which is the inverse of x and y, which is also the element of complex number. So inverse is also exists for multiplication. Distributive property also exists for complex numbers. That means complex number form again an abelian group with respect to multiplication as well, right? Then we have a conjugate of complex number. Let's say we have a complex number 2 plus 3 iota. So conjugate will be 2 minus 3 iota, right? Let's say I have a complex number 2 minus 3 iota. So in that case, conjugate, this bar denotes conjugate of z. It will be 2 plus 3 iota. Let's say I have z as minus 2 plus 3 iota. So conjugate z will be minus 2 minus 3 iota. Let's say I have z is 2 minus 3 minus 2 minus 3 iota. So conjugate z will be minus 2 plus 3 iota. So these are the, what I should say, these are the conjugate for the complex numbers. What it means, the sign of iota will change. Rest term will become unchanged. The sign of this first term will remain unchanged. The values will remain unchanged. Only the sign of iota will change. Then it is known as conjugate of complex number, and this is the notation. This is the notation z bar, right? Only the sign of iota will change, then it is known as conjugate of complex number. Let's say if I want to find z bar of bar, means conjugate of conjugate, then it will be minus 2, and again the sign of iota will change, that will be minus 3 iota. So z bar of bar is equals to z, right? Then z plus z bar, z is x plus iota y, z bar is x minus iota y. It is equals to 2x, or we can say real z. Real z means real part of z, which is x. Then z minus z bar, which is 2 iota y, or we can write y as imaginary z. Z times z bar, if z is x plus iota y, z bar is x minus iota y, right? So x plus iota y times x minus iota y, that is a plus b, a minus b, that is a square minus iota square y square. The value of iota square is minus. Minus minus will convert into positive sign. So z times z bar is x square plus y square. These are few properties and definition of conjugate of complex numbers. Then z plus z1 whole bar is equals to z bar plus z2 bar. Similarly, this is multiplication and quotient rule, right? Then modulus of complex number. Let me first take your questions. If you have any problem in conjugate of complex number or complex number, please raise your hand. No? Okay, so let's continue with modulus of complex numbers. So if z is x plus iota y, if z is x plus iota y, then modulus is denoted by this mod z. This is the notation for mod z, and the value of mod z is root x square plus y square. Square of this term plus square of this term and then root. This is the mod z. Mod z cannot be negative because whatever the value of x, whether it is positive or negative, because of this square, it will convert into positive value. Because of this square, this whole term will convert into positive value. The entire term will be positive. So mod z is always greater than or equals to 0. This is the example of mod z. That this is 3 square plus minus 4 square. This minus will convert into positive sign. It will be 5. Right? So this is modulus of complex number. Here we have few properties of complex numbers, that is z times z bar is mod z square. Mod z is equals to mod z bar. Just a minute. Yes. So z times z bar is z square. Modulus z is equals to modulus z bar. Let's say I have z is x plus iota y. Z bar is x minus iota y. Mod z will be root x square plus y square. Here mod of conjugate z will be root x square plus minus y square, and both the terms are same, right? So mod z is equals to mod z1. The value of real z lies between minus modulus z to modulus z. Mod z1 z2 is equals to this value. These are few inequalities. These are the inequalities for modulus function, right? So these are few properties of modulus of complex number. Now geometrical representation of complex number. Let's say I would like to denote 2 plus 3 iota in a plane. So how I'll draw it? This x-axis is known as real axis, and the y-axis is known as imaginary axis now, right? 2, that means the 2 unit distance from origin on real axis, because 2 is the real part. So 2 unit distance, let's say it is 2. Then 3 iota. 3 means the 3 unit distance from origin on imaginary axis. Because of this iota, I will take 3 on imaginary axis. So where we can denote 2 plus 3 iota? This is the point where we can write 2 plus 3 iota. This is the point, right? This is the explanation. X is called the real axis, y is called imaginary axis. On x-axis we'll calculate the real number, and on y-axis we'll calculate the imaginary number. So in that way we can find the location of the point complex number on plane, right? Then geometrical what will be the value of cos theta? Okay, one more thing, what is the value of theta? If we connect this point to origin, if we connect this point to origin, the angle between this is known as r, radius vector. So the angle between radius vector and origin and x-axis in the anti-clockwise direction is known as theta, right? Now what will be the value of cos theta? If this term is x, this term is r, and this term is y, let me draw this triangle x, r, y and theta. So yes, so cos theta will be x by r and sin theta will be y by r, right? So the value of x will be r cos theta and value of y will be r sin theta. X plus iota y will be r cos theta plus iota sin theta. If we substitute the value of x as r cos theta, the value of y is r sin theta, it will convert into r times cos theta plus iota sin theta. So this is the polar form of complex number, or we can say the trigonometric form of complex number, right? Now what will be the amplitude of complex number? If we square and add this equation, if we square and add this equation both sides, so left hand side will be x square plus y square and the right hand side will be r square only, because we have one trigonometric identity, sin square theta plus cos square theta is 1. So right hand side will be r square, and the value of r is root x square plus y square, which is the modulus of z. Modulus of z is also root x square plus y square. So we can say mod z is equals to r, which is equals to root x square plus y square, right? Again, theta is known as argument or the amplitude of z, and the value of theta is, and it can be denoted as theta is equals to amplitude z, and the value of theta, as we know that the value of from here the value of sin theta is y by r, the value of cos theta is x by r, sin theta is y by r, cos theta is x by r, sin theta by cos theta. If we divide both the terms, we'll get y by r upon x by r, which is y by x, right? And this is tan theta. So theta will be tan inverse y by x, right? This is the amplitude of complex number. This is the value of theta, which is amplitude of complex number z, and this is the notation of amplitude. Now we have few properties of amplitude. Let's say we have two complex numbers z1 and z2. The subtraction of z1 and z2 can be written by this equation, and mod is given by this, which is known as distance between 2 points z1 and z2. Cos theta plus iota sin theta can be briefly written as cis theta. Cis theta can be written as cos theta plus iota sin theta. Then amplitude z1 times z2 can be written as amplitude z1 plus amplitude z2, and amplitude z1 by z2 can be written as amplitude z1 minus amplitude z2. These are few basic properties. No proof is required. Now we know that cos theta is x by r, sin theta is y by r, so the value of r will be root x square plus y square, that we have already discussed as well. Then these are few series expansion of e raised to x, sin x and cos x. So e raised to iota x will be if the expansion of e raised to x is 1 plus x factorial 1 plus x square by factorial 2 plus x cube by factorial 3 and plus so on. Then e raised to iota x will be iota x whole square, iota x whole cube and so on, right? Iota square will be minus 1, iota cube, iota times iota square, and the value of iota square is minus 1, so we can write it as iota. Iota raised to 4 is iota square times iota square is minus 1, 1, right? So if we substitute the value of iota square, iota cube like that, and if we separate the real and imaginary part, we'll get it as cos theta plus iota sin theta. So e raised to iota x is cos theta plus iota sin theta, which is Euler's formula. Now the exponential form. Let me take your questions. If you have any doubt, please raise your hand. If you have any doubt, please raise your hand. Okay, then the exponential form of a complex number. We know that z is x plus iota y, x is r cos theta, y is r sin theta. If we substitute all the values, cos theta plus iota sin theta can be written as e raised to iota theta, that we have discussed in the previous slide. So z equals to r e raised to iota theta, which is the exponential form of complex number. Now here we have few examples. Express the following complex number in the polar form and find their modulus and amplitude. So first of all we need to write it in the polar form. Polar form is r times cos theta plus iota sin theta. Now by comparing real and imaginary part, real part is root 3, here real part is r cos theta, here imaginary part is 1, here r sin theta, right? Now by square and add both the terms, r square cos square theta plus r square sin square theta equals to root 3 square plus 1 square. If we take r square common, sin square plus cos square will convert into 1. 3 square is 3 plus 1 4. That means the value of r is 2. Right? Now we know that the value of cos theta is root 3 by 2 and the value of sin theta is 1 by 2. Because the value of r is 2. If we substitute r here, cos theta will be root 3 by 2, sin theta will be 1 by 2. Right? Then theta, the value of theta which satisfy both the terms cos theta and sin theta is pi by 6, because cos pi by 6 is root 3 by 2 and sin pi by 6 is 1 by 2. Right? So this is the amplitude. Then this is the polar form. If we substitute the value of r and theta, we'll get the polar form. Then modulus, that is root x square plus y square, that we can write it as root 3 square plus 1, which is 2. Right? So this is, in that manner we can write the complex number in polar form. We can find the modulus and amplitude. Here we have one more example. If a is cos theta plus iota sin theta, where theta lies between 0 to 2 pi, we need to prove that 1 plus a upon 1 minus a is iota cot theta by 2. 1 plus a, here we will substitute the value of a, and here also we will substitute the value of a, right? So 1 plus a upon 1 minus a, right? Then we have few trigonometric identities, that is 1 plus cos theta is 2 cos square theta by 2, sin theta is 2 sin theta by 2 cos theta by 2, and 1 minus cos theta is 2 sin square theta by 2, right? 1 plus cos theta to cos square, sin is 2 sin theta by 2 cos theta by 2, same as denominator. Then we'll take 2 and cos theta by 2 common from numerator, and 2 and sin theta by 2 common from denominator, right? 2 will cancel out. Cos by sin can be written as cot. If we take if we one more thing, here the denominator and numerator we cannot cancel it, right? So what we'll do, we'll multiply and divide by iota. Multiply this iota with this term, so it will convert into iota sin theta and iota square cos theta by 2. Iota square is minus 1, minus minus plus, so it will be cos theta by 2 plus iota sin theta. These two terms will cancel out and we'll get iota cot theta by 2, right? Then if x plus iota y is given by this term, we need to prove that x square plus y square is equals to x square plus y square whole square equals to this. So x plus iota y is given, x minus iota y will be conjugate, that is a minus iota b upon c minus iota d. We'll change the sign of iota, right? Then multiply x plus iota y and x minus iota y. Multiply both these terms, this one and this one. The left hand side will convert into this term and the right hand side will convert. Now we have one property, a plus b and a minus b is a square minus b square. And if we have a plus iota b and a minus iota b, it will be a square minus iota square b square. Iota square is 1, so it is a square plus b square. Similarly, for c and d, we can solve these two terms. Now by taking square both sides, the right hand side square root will cancel out and we'll get the required term. Right? Then moving towards the next topic, before moving towards the next topic, I would like to take your questions first. If you have any query, please raise your hand. Okay, so in that case, let's proceed. This is the Morwer's theorem. What it is? If we have a term like cos theta plus iota sin theta whole power n, it will convert into cos n theta plus iota sin n theta. Like if I have cos theta plus iota sin theta whole power, let's say 2. So by De Morgan's theorem, this whole power will shifted in the angle of sine and cos. So it is cos 2 theta plus iota sine 2 theta. This is the De Morgan's theorem. The value of n can be in fractional form, p by q form as well. Then also it is applicable, right? The power, the whole power will shift in into the angle of sine and cos theta, right? For example, if we want to prove this step where n is any integer, what we'll do, first of all, we'll convert this term into polar form, right? This term should be in sine and cos form, then only we can use De Morgan's theorem. So the polar form, to find the polar form, first of all, we need to find the value of r, right? So r is root x square plus y square. Here the value of x is minus 1, that is root 1, and y is root 3, so it will be 3 or 2. The value of r is 2, right? Then the value of cos theta is x by r. Cos theta is x by r. The value of x is minus 1, the value of r is 2. Similarly, sin theta is y by r. The value of y is root 3 by 2. It is equals to 2 pi by 3, right? So the polar form is x plus iota y can be written as r cos theta plus iota sin theta. R is 2, theta is 2 pi by 3. So this is the polar form of the given term, this first term. Similarly, the second term can be written in the polar form, right? So the given equation, the left hand side of the given equation can be written in the polar form in that manner by using this power as well. Now by De Morgan's theorem, this power will come in the angle of sine and cos theta. This 3n will shift over there. 3 will cancel out, we'll get 2n pi in the angle, right? Then the value of cos 2n pi is 1 and the value of sine 2n pi is 0, right? So in that manner we can solve the complex numbers. Similarly, in this question again, we need to solve this left hand side and prove it is equals to the right hand side. So again 1 plus cos theta is 2 cos square theta by 2. Sin theta is 2 sin theta by 2 cos theta by 2, right? If we substitute the value of 1 plus cos theta and sin theta in the left hand side, and if we take cos theta by 2 common from both these steps, and if we take the limit n, the power n, it will convert into 2 raised to n cos theta by 2 whole power n, then 2 raised to n cos theta by 2 whole power n. Again this n will shift in the angle, right? Then the value of cos n theta by 2 and the value of sin n theta by 2 can be written, right? Sin n theta by 2 will cancel out. Then the nth root of a complex number. By this method we can find the nth root of a complex number. I'll discuss through this example. Find the cube root of root 3 plus iota and represent them on the argand plane. Also find their continued product. So root 3 plus iota can be written as r cos theta plus iota sin theta in the polar form. The value of r cos theta is root 3, the value of r sin theta is 1, the value of r is 2, the value of sin and cos theta, the value of theta, right? So the root 3 plus iota can be written in that form as polar form. Cos of this angle plus iota sine with this angle can be written as CIS. As I told you, cos theta plus iota sine theta can be written as CIS theta, right? Here the theta is 2 and pi plus pi by 6. Now the whole power of 1 by 3 can be written as 1 by 3. Now by using De Morgan's theorem, it will convert into 2 raised to 1 by 3, and for CIS it will convert in, this 1 by 3 will shift in the angle of CIS. Now we would like to find their continuous product. Cubic roots, 3 roots, we would like to find 3 roots and their continuous product. So 3 roots, when we will take any 3 consecutive values of n, that is let's start with 0, 0, 1 and 2. If we substitute n equals to 0, we'll get this term. For n equals to 1, for n equals to 2. Then we'll find the product of these 3 terms. This is the product of these 3 terms, right? Then 1 omega and omega square are the cube roots, and the value of omega is cos 2 pi by 3 plus iota sin 2 by 3, and these are the 4th root of unity. Then the limit and continuity, let's discuss the limit and continuity of complex numbers. Let's say we have a function complex number, the fz, and the limit is f1 for this function, and for the second function the limit is f2. Then here we have few basic properties of limit, which is for addition and for subtraction as well, for multiplication and for quotient, right? For example, if we want to evaluate the limit for this function when z tends to iota, what we'll do? We'll just substitute the value of z, that is z tends to iota. So we'll substitute z tends to iota, right? Iota cube will be minus iota, iota square is minus 1. Because of this minus, it will convert into positive sign, and this is the limit. Similarly, we can find the limit for this second function. Simply what we'll do, we'll substitute the value of z, that is 1 minus iota 5 z square. So 1 minus iota square minus 2 z is 1 minus iota plus 2 upon 1 minus iota plus 1. So 5 1, the value of 1 minus iota square is 1 plus iota square minus 2 iota. Iota square is minus 1, that is minus 2 iota. Minus 2 iota. Minus 2 minus minus plus 2 iota plus 2 upon 2 minus iota. Minus 10 iota plus 2 iota plus 2 upon 2 minus iota. Minus 8 iota plus 2 upon 2 minus iota. Right? Then continuity of the function. Here we have few properties for derivative. The the differentiation of constant term is 0. If we multiply the complex number with any constant, this is complex number, if we multiply it with any constant c, then we can rewrite in this form, c times differentiation of complex number. This is the property for addition and for as well as subtraction, multiplication and quotient. These properties are same as differentiation. The only difference is here fz and zz are now complex numbers. The differential properties are same, only the difference is f and g are complex numbers. Let's say if I want to find the derivative of these three terms, what I'll do? Differentiation of 4z cube. Differentiation of z cube is 2z square. Then differentiation of z square is 2z. 3 plus iota is constant. Then differentiation of minus 5z is minus 5. Differentiation of 4 is 0. Right? Then differentiation of second term, differentiation of this term will be 5 4z cube minus iota is constant, differentiation of z cube is 3z square, 8 minus iota is constant, differentiation of z square is 2z, and differentiation of 6 iota is 0 because it is a constant term. Similarly, we can find derivative for third term. Right? Then the analytic function. Okay. If you have any problem or query, please raise your hand. No? Fine. So, can we move forward? Fine. So, this is analytic function. What is analyticity of the function? A complex number is said to be analytic if it is differentiable at every point in some neighborhood. And Cauchy's equation, this equation is known as Cauchy's equation, where del is the partial differentiation. What is the statement? If the complex number is continuous in some neighborhood point and it is differentiable at z, then at the point z, the first order partial derivative of u and v exists and satisfies this equation. If a complex number satisfies this equation, that means it is necessary that it is Cauchy-Riemann equation, but it is not a sufficient condition. Right? Here we have one example. The value of u, the real part, this is u. The imaginary part is written as v. Right? And we need to prove this equation. If u and v prove this equation, that means it is analytic, otherwise it is not analytic. So first of all, find del u by del x. If u is 2x square plus y, and we need to find the partial differentiation with respect to x, that means y is constant, so it is 4x. Then del u by del y, it is 1. Then del v by del x, minus 1, and del v by del y, 2y. Right? Now del u by del x is equals to del v by del y? No. If del u by del y is equals to minus del v, here one minus sign is missing. There is some typo error, I guess. Del u by del y should be equals to minus del v by del x, right? Yeah, this minus sign is there. There's one typo error, right? So this condition is not satisfying by u and v. That means it is not an analytic function. Then show that this function satisfies CR equation. So this function is in the form of z and we want real and imaginary part. So we'll substitute the value of z, that is x plus iota y. It is x square minus y square plus 2 iota xy plus x plus iota y. So it is x square plus y square plus x plus iota y plus 2xy, right? So this real value is u and this imaginary value is v. Again we will find the del u by del x, del u by del y, del v by del x and del v by del y. Now del u by del x is equals to del v by del y and del u by del y is equals to minus del v by del x. So the given function is analytic and it satisfies the CR equation, right? Again we need to prove that it is analytic. That means we need to prove the CR equation. This one is u and this one is v, right? Here again we need to prove the CR equation. First of all we'll substitute the value of z, then we'll separate the real and complex part, that is u and v. Then we'll find the partial derivatives. We need to prove that this function is not analytic. That means it will not satisfy the CR equation. So u is equals to y and v equals to x. We'll find the partial derivative and we can see that del u by del x is equals to del v by del y and del u by del y is equals to del v by del x. But CR equation says that it should be equals to minus del v by del x, right? So it is not analytic. Similarly, the second step, the second term. So here in today's lecture we discussed the concept of complex numbers, addition, multiplication of complex number, conjugate of complex number, modulus of complex number, geometrical representation, amplitude of complex number, exponential form, De Morgan's theorem, the nth root, limit, continuity and differentiability of complex numbers and their properties. Also in the last we discussed the analytic functions. This is the basic concept of complex number.